Bismillahirrahmanirrahim. Kita sambung lagi dengan reaction of alkenes. So, alkenes can undergo two types of reaction, addition reaction and oxidation reaction. Under addition reaction, we have five reaction. First, hydrogenation, halogenation, halohydrin, hydrohalogenation, and hydration. Hydrogenation means add hydrogen. Halogenation means add halogen. Halohydrin add H and OH. Hydrohalogenation add hydrogen and halogen. Hydration add water. While under oxidation reaction, we have four reactions. Combustion, epoxidation, ozonolysis, and hydroxylation. Okay, so about reactivity of alkenes. What does it mean by reactivity of alkenes? Reactivity means how reactive is that compound. Alkene is more reactive than alkenes, because alkenes has a carbon-carbon double bond that consists carbon-carbon double bond is actually sigma bond and pi bond. One is sigma, one is pi bond. Pi bond is easy to break, compared to sigma bond. Means that pi bond is weaker compared to sigma bond. So that's why it is easy to break pi bond compared to sigma bond. Pi bond will break and sigma bond will remain. The pi electron in the pi bond or in the double bond acts as a sources of electron. It acts as a Lewis base because Lewis base is a substance that can donate electron. Alkenes are reactive towards electrophile, which are attracted to the negative charge of the pi electron. Pi bond will broken. Each carbon atom becomes active site, which can form a new covalent bond with another atom. So when the okay, if you look at this, actually bond is consists of sharing two electron. Kat bond sini pun ada dua electron, bond sini pun ada dua. So we have sigma and pi. Okay, the one that will break is the pi bond. So one electron goes to this carbon, produce two active sites. Produce two active sites. So this will be it will have two electron here. So one electron. So this will be negative. So this negative side can attract electrophile. Electrophile is the positive species. So for example, we have H plus. So this H plus will form a bond with this carbon. And another H plus form a bond with this carbon. So that is the reaction of alkenes. Addition reaction is a reaction in which an unsaturated molecule becomes saturated. Unsaturated means it has double or triple bond. Become saturated, become single bond by addition of a molecule across a multiple bond. So we have double bond, CC double bond, CC triple bond, and C double bond O. So all these bonds can be break and can be added with another atom, become saturated compound. Characteristic of the addition reaction is the pi bond of the double bond is broken and two single bonds are formed. and only one product is obtained at the end of the reaction. And the product obtained is a saturated organic compound. Yeah? For example, this one sama juga macam saya tunjuk tadi. We have this double bond, so the bond will break, and the electron is used to form a bond with another species. Yeah? So this is general mechanism for addition reaction. Yeah? The CC double bond is electron-rich part of the alkene's molecule. So the reaction is only occur at this center. And electrophile is the electron-seeking species. Yeah? Nucleophile is the nucleus-seeking species. So electrophile is normally positive species. Yeah? So for example, this one, yeah, this is delta plus, this is delta minus. So electron will attract or attack the positive center of this species. So it will form a bond. So this will become positively charged. And when this becomes positively charged, this negative species will attack this center and form another bond. Okay, so mechanism for electrophilic addition consists of two steps. The first one is formation of carbocation ion from the attack of electron daripada double bond into the positive side of the species. So we get a carbocation ion with the negative species, and this negative species will attack the carbocation ion and form another bond. Okay. Under addition reaction, we have addition of symmetrical reagent. Yeah? So symmetrical reagent is hydrogen. Yeah? So this reaction is called hydrogenation. Addition of hydrogen to double bond or triple bond to yield saturated product. And this in this reaction, alkenes will combine with hydrogen with the presence of catalyst. Catalyst can be either platinum, nickel, or palladium. Yeah, so this is the catalyst. This is the example of the addition reaction into ethene to form ethane. Yeah? The condition for this reaction, we need a catalyst. If we use platinum and palladium, the temperature can be between 25 to 90 degrees Celsius. But if we use nickel, we need to use a higher temperature in the range of 140 to 200 degrees Celsius. Yeah? So for addition of symmetrical reagent, this is the mechanism that show how does this molecule attach or absorb onto the surface of catalyst. First, the hydrogen and alkenes are absorbed on the metal surface, on the catalyst surface. Once absorbed, the hydrogen insert across the same face of the double bond, and the reduced product is released from the metal. So once the hydrogen attached to this carbon that has double bond, once the reaction complete, the alkene product will be released from the catalyst. Yeah? The reaction has the same stereochemistry. Yeah? Addition of two substituents to the same side of the double bond. Again, addition of symmetrical reagent almost seem basic, but in this reaction we add halogen. Instead of hydrogen, we add halogen. The condition for this reaction, it must be in the inert solvent. Yeah? Alkenes react with halogen at room temperature and in a dark situation, because it is very reactive. Reactive means easy to react. So even at room temperature or and in a dark situation pun dia boleh react. Shows that how reactive is the alkenes. Halogen is usually dissolved in an inert solvent such as dichloromethane and tetrachloromethane. Iodine will not react with the alkene because it is less reactive than chlorine and bromine. So iodine, it is seldom being used because it is not very reactive compared to chlorine and bromine. Yeah? But fluorine is very reactive. Kenapa tak guna? Because the reaction will produce explosions. So we will not do this kind of reaction, yang very dangerous. So this is example. Ethene react with bromine in inert solvent to produce 1,2-dibromoethene. Okay. This is the general mechanism. In the step 1 is the formation of halonium ion. The carbon double bond will attack one of the halogen, form halonium ion. Okay, then this halonium ion will, has a positive charge, will be attacked by this negative charge and form another bond here. Okay, X attack from the back side. Okay. Tapi kenapa tak ada dia punya gambar ni? So this is example of addition of symmetrical reagent or halogenation of alkenes. So this double bond react with bromine in CCl4 to get 2 bromine atom here. And this propene react with chlorine to get 2 chlorine molecule here. And then, in addition reaction, we have addition of unsymmetrical reagent, which is Markov-Nikov rule. Okay, tak apa, nanti saya summarize balik. Addition of unsymmetrical reagent need to discuss the Markov-Nikov rule because we have different atom. Kalau yang tadi XX, tak kisah dia nak masuk mana-mana. But in this case, we have hydrogen and halogen. So halogen will go to which carbon, halogen will go to which carbon. That will follow Markov-Nikov rule. This rule states that in addition reaction, the more electropositive atom of the reagent will be added to the carbon that has greater number of hydrogen. Okay, more electropositive. Kalau if you still remember, electronegativity value untuk setiap atom tu, hydrogen, dia punya value is slightly positive lah, means that dia lebih electropositive compared to iodine. So electropositive atom will go to the carbon that has greater number of hydrogen. So this hydrogen will go to this carbon, the iodine will go to this carbon. But in this case, we can also have major and minor product juga. This is minor because in this reaction, this is minor, this is major because in this one, hydrogen attached to the carbon that has less hydrogen. Yang kita nak go to the carbon that has more hydrogen, so this will be major product. For example, ini tak apalah, this one you boleh baca sendiri. Okay. And the reason why addition of unsymmetrical reagent follow Markov-Nikov rule is due to the stability of carbocation ion. Secondary carbocation ion is more stable than primary carbocation ion due to the electron donating effect of alkyl group. The greater the number of alkyl group on the carbon atom that bear the positive charge, the greater the stability. So, kalau kita tengok dia punya mekanisme, yang masuk dulu adalah hydrogen. So hydrogen will go to the carbon yang less, yang more hydrogen because it will produce carbocation ion with high stability. So you must remember the order of carbocation ion stability. This is methyl carbocation ion, primary carbocation ion, secondary and tertiary. Methyl is the least stable, tertiary is the most stable. Nanti kita akan tengok dalam dia punya mechanism. So we stop here.